Quick review, section 1.5, combinations of functions. We're going to go through the first two objectives. Students will be able to add, subtract, and multiply, and we might do a couple division functions together. Students will be able to compose functions together. This is that open circle. It's called a composition. So we're not going to go through adding, subtracting graphically. All right, let's go and get started. Okay, so the first one looks at subtracting these two functions at a particular expression, the 4 plus c. So when you're looking at what this is, interpreting it, this is asking us to take the difference of g and h. How do we know it's a difference? Let me go ahead and pull a highlighter. It's this symbol in here. So this is not the distributive property or foiling or whatever is coming to your head. When you see lowercase letters, it's talking about you're going to do something with the function. Add, subtract, multiply, divide, the composition, evaluate, and so on. What we're going to evaluate at is a 4 plus c. So the way I like to approach this is first evaluate it separately. So I'm going to take g of n, let me grab the color. Instead of g of n, I'm not going to look at n. I'm going to take the n out. I'm going to fire the n. And instead of his place, I'm going to put 4 plus c. So I'm evaluating g at 4 plus c. That's what I'm really doing. So let's go and do that. So instead of this n that I crossed out, I'm going to replace it with that expression, which means that quantity. So it's 3 times the quantity, 4 plus c plus 1. Now use your pre-algebra, algebra 1 skills, and you simplify. Distribute means distribute to every term in that quantity. 3 times 4 is 12, plus 3z, carry down the plus 1. These are like terms. So I have 3z plus 13. Now we're going to do the same thing for h of n. So wherever I see an n, I'm going to say, he's gone, and he's gone. Instead of his place, I'm going to replace it with 4 plus c. Notice I kept the negative 2, the exponent, the plus, the 2. This n is going to get replaced by 4 plus c. What is that going to look like? Let me do it on the side here. So we're finding now h of 4 plus c. And in fact, I can see it in advance. I'm going to have to square it. And when I square binomials especially, I like to have the variable first. So instead of h4 plus c, I'm going to write z plus 4. It's the same thing. So now I'm going to, wherever I saw an n, I'm going to replace it with the z plus 4, keeping everything else identical. Negative 2, parentheses, z plus 4, squared, plus 2 times the quantity, z plus 4. And then your job is to simplify it. So if we multiply this out, we get z squared plus 8z plus 16 using FOIL or the box method. Distribute correctly, please. 2z plus 8. Okay, almost there. Distribute. Notice we're distributing down to 3 terms. So now I'm going to get negative 2z squared minus 16z minus 32. I didn't do anything with these two terms, so I just carry them down. Now you're going to combine like terms. I don't have a z squared. Let's see, I do see I have these two are like terms and these two are like terms. So then 2z squared, let's see, minus 16 plus 2 gives me minus 14z. Negative 32 or minus 32 plus 8 will give me a negative, let's see, that's a 24. So now we found each one separately. Now we have to find their difference. So I'm going to take these two, this one right here and this answer right here, and take the difference of these two. Okay, be really careful. So I'm going to draw a line here. So it'll look like 3z plus 13 minus this entire quantity. So you have to indicate that by putting parentheses. Minus 2z squared minus 14z minus 24. And then you go ahead and use your pre-algebra 1 and algebra 1 skills to simplify this. Again, distributing to all three terms. That's a negative, like a -1. So we have 3z plus 13, negative is a positive. Negative again is a positive. In fact, they're all going to be positive. And plus 24. Okay, and then you go about looking for like terms. 3z, 14z, those are like terms. 13 and 24 are like terms. This one didn't have a like term, so I'm going to carry it down. 2z squared plus 17z. 13 and 24, that's going to give me 37. So this is my final answer. Right? So I had to find each one separately, and then I'm taking the difference of the two to get my final answer. Okay, let's go ahead and try another one. Okay, so now this is a quotient. We're dividing. This one, we're finding it at this particular value and at this expression. These are two separate problems, but we're going to use the same functions. Okay, so let's start with this one. So again, I'm going to start separately. I'm going to first find f of -2, then find g of -2, and then I'm going to take the quotient of the two. So let's go and do that. F of -2, I'm going to replace that x with -2. So that's -4 minus 2 is -6. G of -2, it's 4 times -2 plus 1. See, that's -8 plus 1 is -7. Take the quotient, which is 6/7. Negative is a positive. Okay, so for this particular combination of functions, this is going to be my answer. Next one. Still looking at the quotient, but this time I have an expression. So I'm going to take wherever I see an x and replace it with 3t. So f of 3t is going to be, so wherever my x is, take him out, he's fired, replace it with 3t. You don't need a parentheses because it's a single term. Minus 2, you do need to worry about order operations because this is 6t minus 2. I cannot combine those are not like terms. Follow through in the same thing for g of 3t. Let's see, here's this x, so fire him. Instead, put it in its place at 3t. It's 4 times 3t plus 1. That gets me 12t plus 1. Take the quotient, so it'd be 6t minus 2 over 12t plus 1, and that becomes your answer. Be careful, do not cross cancel these. You cannot do that unless it's a product. Okay, let's try the next one. Okay, so this is giving us two functions. We need to find the product. Again, you have to look at this symbol here. Oops, let's get the highlighter and get the yellow. That's going to tell you what it is that you need to do. Is it adding? Is it subtracting? Is it multiplying or dividing? And again, we're going to first find g of x plus 1, then find h of x plus 1, and then we're going to find the product of the two. Now, let's go on. So g of x plus 1. Wherever I see an x, that guy's gone, and I'm going to replace it with x plus 1. If I write this, that's incorrect. In fact, let me put the plus 4. It's 2 times that quantity. And then this becomes 2x plus 6. Do the same thing for h at x plus 1. So wherever I see that x, instead of him, I'm going to put an x plus 1. So that's 3 times the quantity, x plus 1, minus 4. Simplify, this would give you 3x. That would be a plus 3, and minus 4 would be minus 1. So those are the two answers separately. Now we have to find the product of these two answers. Okay? So let me draw a line to divide it. So what looks like mathematically is g times h of x plus 1 is going to be this product, 2x plus 6, 3x minus 1. Okay? I like to use the box method to multiply. So it's an area model, 2x plus 6, 3x minus 1. Draw my little box or rectangle or square in this case. That's 2 by 2. And then you just fill in each one. 3 times 2 is 6. That's x squared, negative 2x, 18x, and minus 6. And then you look for like terms. Most of the time, they're sitting on this diagonal right here. So then I have 6x squared plus 16x minus 6 is the product, and that's the answer we're looking for. That's our final answer. Alright, let's keep going. Alright, so on the next problem, we're going to look at the composition. So that's composing functions together. So composing functions together is we're literally putting one function inside another. And again, it's all about the shorthand, the notation. This right here, what does this mean? G, an open circle F. This is read G of f of x. G of f of x. Okay, and what does that mean? We're going to take this entire function and we're going to replace it in for this x. That's what we're really doing. So I have some steps here. I want to go ahead and ignore those steps and just talk through it. Okay, so the way I taught it in class is, okay, look at this first function here, the letter, whatever letter it is, go to it, okay, that's g of x, instead of the x, and it might be in 2 or 3 different places, replace it with a blank or a box. And that's what I'm going to do. I'm going to keep everything else the same. The numbers, add, subtract, exponents. Just take that x, say, oh, something in its place is going to be going there. 3's there, the plus 1. Well, what goes in its place is this guy right here. So it's going to be this in that box. 1/3 x minus 3. All of them. And then we just clean them up mathematically, which will look like 3 times the quantity, 1/3 x minus 3 plus 1, and then you simplify. Distribute the 3. 3 times 1/3 is just 1. Then 9 plus 1 x minus 8. That's the composition. So it looks kind of similar, but you have to interpret what you're doing. You're inserting a function inside another function. It's taking a function of a function. Okay. Alright, one more. Okay, so same idea. We're composing functions together. This time we have f, open circle, g. What does this mean? We're taking f of g of x. So we're taking this g of x, and whatever that function is, we're putting it in its x place for the f. So you start out with the f. So I'm going to start by looking at the f of x and say, okay, there's my x. Instead of the x, I'm going to cross them out and replace them with a box. Okay, so I'm going to keep everything else the same. The 2/3 is still there. So I'm going to have a box or a rectangle or a blank spot. 2/3. Now this guy is going to go inside the box. So x to the 6th, all of him goes inside. Okay, so clean him up a little bit. Looks a little bit nicer. And then simplify. When we have a power to a power, we multiply the exponents. So multiplying 6 times 2/3, what does that look like? 6 over 1, you can cross cancel. 3 goes into 1, 3 goes into 3 once, 3 goes into 6 twice. 2 times 2 is 4. So you get x to the 4th. So that's the composition between those two functions. Alright, this was a quick review for section 1.5.